This video will show you how to check for element-wise equality between two PyTorch tensors using the PyTorch EQ equality comparison operation. First, we import PyTorch. Then we print the PyTorch version we are using. We are using PyTorch 0.3.1 post 2. Let's create our first tensor using the PyTorch ones operation. So we use torch.ones, and we want it to be 2 by 3 by 3, and we're going to assign it to the Python variable pt_tensor_x_1. Let's now print the pt tensor x1 Python variable to see what we have. And we see that we have two matrices, each of which is 3 by 3, and it's all ones. And it's a PyTorch float tensor. Next, let's manually create our second tensor using the PyTorch float tensor operation. So I say torch.float tensor, and then we're going to pass in our construction. You can see that it is made up of two 3 by 3 matrices. The first column is 5s, then 1s, 1s, and then the second matrix, it's column of 1s, and column of 8s. We construct this tensor this way so that it's easy to visually do a manual element-wise equality comparison. Next, let's print the pt tensor x2 Python variable that we just created to see what it shows up as. And we see that it's a torch float tensor of size 2 by 3 by 3. First column is 5 in the first matrix, and the second matrix, the last column, is 8s. Now let's do the element-wise equality comparison between pt tensor x1 and pt tensor x2 Python variables using the PyTorch EQ operation. Then we're going to set the result equal to the Python variable equality_tensor_x. Let's print the equality tensor x Python variable to see what we have. We see that we have a tensor that's two matrices, where each matrix has 3 rows and 3 columns. Each matrix is full of 1s and 0s. In this case, the 1s represent the true Boolean value, and the 0s represent the false Boolean value. Doing the visual manual check, we see that the first column of the first matrix is all 0s, which is as we expect because the number 1 is not equal to the number 5. Remember, we had 1s for all pt tensor x1, and then we had 5s in the first column, so we see 0s here. The rest of the columns are all 1s because we had 1s in the second column and 1s in the third column for both matrices. In the second matrix, we see that the third column is all 0s, which is what we expect because the number 1 is not equal to the number 8. Remember that the second example Python variable had a column of 8s in the second matrix, whereas the first one had a column of 1s. So 8s are not equal to 1, so we get a column of 0s. Perfect. We were able to check for element-wise equality between two PyTorch tensors using the PyTorch EQ equality comparison operation.